So with these kinds of questions, there is a conceptual way of thinking about everything, and I'm going to mention that, but I also just want to walk you through how I answer it. Here's one thing I just want to make clear to everyone. Even though this question has a part A, a part B, and a part C written out like this, when you're answering a question like this, you do not have to answer A, and then answer B, and then answer C. What you can do is you can work everything out, and then just write on the side like, oh, this is true from this step, this is true from this step, and I'll show you what that is. So this first one, find the removable discontinuity. Okay, well, let's just do all of our analysis at once. So I know q of x is this function that they have at the top, x minus 3, x plus 3, divided by this over here, x squared minus 7x plus 12. However, I know, because the question's asking me about removable discontinuities, I probably want to factor this. And I know also, because I've been practicing my factoring for the past couple weeks, that x squared minus 7x plus 12 can be factored as x minus 4, x minus 3. Okay. The first thing I see here is that I see there's an x minus 3 that's the same on the top and the bottom. Because of that, I know that I can remove it. However, it was there. And because it was there, that is what we call a removable discontinuity. If x equaled 3, the denominator would be 0 and it'd be undefined. But we're going to get rid of it, and so I'm just going to mark a note here. Removable discontinuity at x equals 3. And we just want to keep that in mind as we're going through this. And so now we have q of x equals x plus 3 over x minus 4. Now at this stage, I'm going to identify two things that I know I can find. The first one being a vertical asymptote. Well, to find a vertical asymptote, I always look in the denominator. Here the denominator is x minus 4. What would make a vertical asymptote? Well, it would be if x minus 4 equaled 0. Sorry, my hair is a mess today. Whatever. Okay. So x minus 4 equals 0. Add 4 to both sides. I see that x equals 4 will be an asymptote because that would make the denominator 0. So x equals 4 is a vertical asymptote. And the last bit that I haven't found, well, I found the removable discontinuity and I showed that. I found the vertical asymptote and I showed that. Well, let's find the zeros. Well, if I look here, I see x plus 3 is in the numerator. In order to find zeros, we care about the numerator. And to find the zeros, we're just going to set the numerator equal to 0. We want x plus 3 equals 0. And so we solve that x equals negative 3 is a 0 of q of x. Great, so we found all three parts. And you could label it if you want to. This is A, this is B. Actually, please do label it just so it's easier for Miss Aduna or I to grade it. This is C. Now you might be wondering, well, what about this x minus 3 over here? Could that have been a 0? Could positive 3 have been a 0? Well, no, because it's a removable discontinuity. That means that at positive 3, let's say 1, 2, 3, the function is going to kind of cross through it, but there's going to be a hole there. And so the function will do something like that. I don't know what exactly it's going to do, but it might look like this. Actually, yes. So we know that there's going to be a hole, and since it doesn't actually touch the x-axis there, it's not a 0. And so we first found the removable discontinuity, and then we identified the vertical asymptote, and then we identified the zeros. You can go in whatever order you want that makes sense to you. My first step that I always take, and I highly recommend you do it, is, oh dear, what just happened? One is factor everything. Then the next step is cancel things, divide things, and in doing so, you find removable discontinuities. Removable discontinuities. Then my step 3, you factor everything, you cancel things, and then step 3 is find vertical asymptotes, and you find that from the denominator, from denom. And then 4, find zeros. And where do we look for that? We look for that in the numerator. If you have any questions, let me or Miss Adu know.